Alrighty, last video here, Kaleigh, for you. So this one we're going to look at both papers because there was something from the book that I assigned, solving exponential equations, and there was something from a CUDA worksheet that I assigned to that had solving logarithmic equations. So we'll see how long this one takes, but hopefully not too long. Alright, so first thing we're asked to do is to solve the equations graphically. So that's just what we did in the very first video that I showed you, where you just graph the left-hand side, graph the right-hand side, find the point of intersection. Okay, so 4e to the 0.1x. Whoops, that's me uploading your videos there. There you go. Whoops, that's not it either. There you go. Okay, clear these out. 4, and then E, you can do it two ways. The ln button next to the 4, okay, if you press second ln, which is short for natural log, right, you get e to the x, but you also have e if you press second divide by 2 there, so your choice. Okay, and now I've already forgotten what I was supposed to be typing in. 4e to the 0.1x equals 60, okay. So 0.1 times x, and then 60. Okay, now I haven't changed my window since that first or second video that we did, so right now my y values are going to be way too high, 2,500, too much, right? My highest y value here is 60, right? Y of 2 equals 60, so I'm going to change my window to be like 70 for my y max. Here's my exponential curve, there's the 60, and there's my point of intersection. So second trace, go down to intersect, and go over to the point of intersection and hit enter, 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 and voila. About 27.08, we'll say. Okay, cutting off some decimal points there. Okay, so there's our approximate solution to the equation. All right, and that's solving it graphically. There you go. Okay, now, number 6 asks us to solve the equation, okay, and give an exact solution, which means we need to be able to solve it using algebra, and then also an approximate solution. Once you get that exact one, we'll type in the calculator to get a decimal. Okay, so here it is, what we're trying to solve here. So first thing we want to do, we want to isolate this exponential. So that means we need to add 10 to both sides first, okay, which leaves us with 6 to the 3x minus 9 power. And if I added the 10 to both sides there, like I showed earlier, right, then it's going to be a 7 over here. Okay, now that I've isolated this exponential, now that I've isolated the exponential here, okay, which is this, I need to use a logarithm to eliminate this base and just get this exponent by itself. You can use any logarithm base that you want. Okay, so you can do log base 2, log base 3, natural logarithm if you want to, doesn't matter here. But most students do tend to prefer using the matching the base of the logarithm to, or matching the base of the exponential to the logarithm. So a lot of students would choose log base 6 here, okay? Log base 6, though, isn't on your graphing calculator. You can still evaluate log base 6 if you have like one of the newer calculators, but I would encourage you, if you're going to try and use your calculator eventually to get like a decimal point or something like that, I would encourage you to use like log, which is log base 10, remember? Like this, right? Or natural log, which is the ln, which is log base e, okay? So one of those two, I'm going to use I'll use natural log because I think I used log for a previous problem that I showed you. So we'll use natural log. So I'll just take the natural log of both sides here. So I'll squeeze the natural log there, and I'll put in the natural log there too. Okay, and then by the properties of exponents, we can bring this exponent out, or by the properties of logarithms, we can bring this exponent of the 3x minus 9 out front of the logarithm there. And so we'll have, actually, just do it this way. 3x minus 9 times the natural log of 6 equals natural log of 7. And we can divide both sides by that natural log 6 to bring it over here. And so we'll have 3x minus 9 equals the natural log of 7 over the natural log of 6. Now there is no rule here. There's no like property that allows us to like simplify this. Okay, you can't just say this is equal to like the natural log of 7/6 here or something like that. Logarithm properties don't work that way. Okay, and when we have division between two logarithms, there's no property that allows us to rewrite this. So we have to leave it like this. Okay, this is in comparison to when we had the natural log of 7 minus the natural log of 6. That is equal to the natural log of 7/6. We can take two logarithms that are being subtracted and then change it to division on the inside, right? But when we have division on the outside like this, it does not equal like natural log of 7 minus natural log of 6 or some other junk there. That's not right, okay? Finally, anyway, we isolate the x, solve for x. You'll add 9 to both sides, and then divide both sides by 3. Okay, well, let me take it one step at a time here. So I'm going to run out of space, so I'll do it over here. So we have 3x equals natural log 7 over natural log 6 plus 9. And then divide everything by 3. So x equals natural log 7 over natural log 6 plus 9, that whole quantity divided by 3. And you can type that mess in your calculator, and you'll get some crazy decimal. Let's see here. I'll do it real quick. Natural log of 7 divided by natural log of 6 plus 9. Okay, gives me about 10.08. Then when I divide that by 3, I get about 3.362. 3 decimal places it says, so 3.362. So there's our precise answer, right? Exact solution, no rounding. And there's our approximate solution right there. Right, last one here, number 12. Word problem, nothing too crazy though. It gives us the equation we're going to use. Price P of a gallon of gas after T years is given by the equation P equals P sub 0 times 1 plus R to the T, where P sub 0 is the initial price of gas, R is the rate of inflation. If the price of a gallon of gas is currently $3.25, how long will it take for the price to rise to $4 if the rate of inflation is 10.5%? So, price equals current price, 3.25, oops, we know what the future price is going to be. We want to know when it's equal to $4, so I'll put the 4 right there. Times 1 plus, okay, R over R is the inflation rate as a decimal though, so 10.5% is going to be 0.105, okay, and then to the T, right, well that's what we're solving for. We want to know how long it's going to take. And so we just solve here, okay. First thing we want to do is isolate the exponential. So I'm going to divide both sides by 3.25 to get rid of that. And 4 divided by 3.25 gives us, and that simplifies to 16/13. Didn't simplify nicely. And then I'm going to go ahead and add these two numbers together here too. So it's 1 plus, so it'll be 1.105 to the T. Okay, and then we are going to use a logarithm. And in this case, I'll use log, okay, log base 10. So I'll do log of this side equals log of this side. Again, using properties of logarithms, we can bring that t out front. So we end up with log of 16/13 equals t times the log of 1.105, and then divide both sides by the logarithm here to the t by itself. Okay, those cancel, so we'll have t is approximately, and we'll just type in my calculator using the log button, log of 16/13 divided by log of 1.105. Make sure you're closing your parentheses around your logarithm, right? Close this parenthesis before you type in that division symbol, okay? Very important. And we get approximately 2.0796. So in this case, we're talking about price. Well, actually, no, we're talking about number of years. How long will it take? So about 2.0796 years. Okay, so there's our final answer. All right, hope that helped. Let me know if you still have more questions, and we can figure stuff out. In the meantime, yeah, take care.